Today we are going to look at the output voltage range of a unity gain buffer to see how high and how low the output voltage can go. Before the unity gain buffer, let's review the active low amplifier first. It is formed by an NMOS input pair, a tail current, and a current mirror. The output is at the drain of M2, and the current mirror is to copy the M1 branch current to the M2 branch. Two key concepts of this circuit are: the sum of M1 and M2 currents is constant, equal to the tail current. The current mirror distributes M3 and M4 currents by varying its output voltage. For example, when the M1 gate voltage is higher than M2's, M1 tends to draw more current than M2. At this time, the current mirror doesn't copy the same amount of current from M3 to M4. Instead, it increases its output voltage at the M4 drain, which equivalently tunes the M4 current smaller and meets the condition of a smaller M2 current. As a result, this gate voltage difference creates uneven current driving potentials, which makes the current mirror adjust its output voltage for less M4 current. The result appears as a voltage gain at the output. If we keep increasing the M1 gate voltage, the output voltage will keep rising and eventually push M4 into triode. On the other hand, when the gate voltage of M2 is higher than M1's, M2 tends to draw more current than M1. To make the M2 current larger, the output of the current mirror will drop until M2 hits the triode region. Now let's go back to the unity gain buffer. The output of the active low amp is now fed back to the negative input. This negative feedback forces the gate voltage of M2 to track the input voltage at the gate of M1. It is interesting that this feedback makes M2 diode connected. As a result, M2 is either turned off or turned on in saturation. The lower bound is no longer set by whether M2 enters the triode region. Instead, it is set by the tail current source. Since this is a buffer, the output follows the input. As we push the input, and therefore the output, downward, the source of the input pair is pushed down with them until the tail source can no longer sustain the intended bias current at VISS. So the range of this unity gain buffer sits between VDD minus V overdrive 4, 1.8 minus 0.1 equals 1.7, and VISS plus VGS 0.1 plus 0.4 equals 0.5. Now let's replace the simple active low amp with a telescopic cascoded amp. Since the active load is a cascoded current mirror, the output voltage changes more sharply with the input voltage difference. The upper bound of the output is set by VDD minus V overdrive 8 minus V overdrive 6, while the lower bound is determined by whether M4 enters the triode region, VB minus VT. Now use it as a unity gain buffer with the output tied to the M2 gate. Tying the input to the output squeezes the output from both sides. It cannot go much below 0.5, or the tail current source loses its headroom. the same limit we just saw in the simple case. And it cannot go much above 0.5 either. Raising the output raises the M2 gate, but M2's drain is held down by the cascode, so M2 falls into triode. Both walls land near 0.5, so there is almost no room left to swing. A telescopic amplifier can hardly work as a direct unity gain buffer.